Now for part two of this, I'm gonna explain this equation here. So this expression. So this is the bigger cloud of my twin tower numeric pictogram. And to understand this, there's several elements. First of all, we're having an infinite summation of terms. We have integral, and this expression inside of the integral, which uses a infinite product notation. So it definitely looks very intimidating, complicated, and kind of scary looking, which is the whole theme of my equations, which is to make scary equations. Now, as I said before, this whole thing reduces to zero. And you may be wondering, well, how does it reduce to zero? Well, first, we'll have to break down this product notation, which has all these terms in here. What this is, and I won't go into the details of how this equation works. I'll just put a short example here. This is pretty much this thing here, with the exception that to the x and in front of the x here, I've added 2 to the power of n, which works with this summation here. What this really means is that it's a product formula, infinite product formula for creating sine x. Once you understand that sine x is just this part here, then it's a lot easier to figure out what's going on. And we start with the summation of sine x, and now we understand what's going on here, right? The next step was to embed pi in here. So you see we have integration from negative pi to pi. What this means really is that if we graph the sine function like so on the Cartesian plane, when we have the sine go from 0 to pi, so that's going to be over here. This length here is pi. What we're doing is we're for the integration, we're asking the area of this region here. However, because we're doing from the negative pi, we're also including this area as well. Now, this area exists in the negative space. In reality, you don't really have, well, I guess a hole or like an empty space can be considered a negative area, but in practice, if you wanted to find the whole area, you would originally take this from 0 and do another integral from negative pi to 0 or something, and reverse the multiply it by 2 or something like that. You get it. But in this case, this simply just reduces to 0. And so that was interesting enough in itself, but I wanted to do something a little bit more tricky. I wanted to include the summation, and so I involved one of my favorite summations, is it 0? This little guy, which I should actually, let's make this 1 into t, just so we have a variable. What this does is basically becomes t, and what it really means is you're adding 1/2 to 1/4 to 1/8 and so on. And so I wanted to do a similar thing here, which means I basically added the 2n, which you can see right here, and incorporate it inside of this integral here. So what happens now that we divide each term by 2n, 2 to the nth, and we also multiply the inside here. So we have this type of thing. So we actually have this kind of integral where I'm adding an infinite sum of these integrals. Now, if you look at the summation and the limits for n being 0, that's just the original equation. Same here. If n is 0 here, the 2 is going to become 1. However, when we're doing the second iteration of that one, that means we're going to have pi divided by 2 here and here. And same here, it's going to be x multiplied by 2. What this really does, and let's write it here, is it condenses the equation to kind of like a half version of the original wave function. And we're asking to add and subtract these areas to the original area that was created. And with each iteration, this wave function gets smaller. And so what we're really doing is kind of like adding these lumps of ever shrinking sine function. At the same time, we're subtracting the same kind of thing on the other side, but it's limited to a finite distance, and this normally would be 4. So if this would be 0, the result would actually be 4. However, because we're doing the other side as well, we're canceling out the whole thing, which I thought it was super interesting, and I incorporated into this equation. And it has nothing to do with 9/11, to be honest, but it's still an interesting expression or equation, and I had fun creating it. I didn't expect to like it as much as I do now, but the final result is 0, and of course, bringing back my original picture. This exponent becomes 0, forcing this to become 1, making this just disappear basically. And 89 divided by 6 has no real meaning. I just kind of like picked the numbers because they were kind of round, sort of like smoke clouds. And I thought I would add a lot more rounder numbers here, but I ended up just going with this. Anyways, this is my memorial math expression for 9/11. I hope you guys enjoyed this. Thank you.